Howdy there, Abram here, and this is my tutorial for a 2-bar intake for FRC. Alrighty, so starting off, let's make a new part studio. Or actually, let's keep it in the same one that we made a drivetrain in. Just go ahead and make a new folder separate from your drivetrain, labeled intake. And in your first part studio here, we're just going to start with our reference geometry. So what reference geometry is basically a set of sketches that is going to give you the basic dimensions and positions of all of the different like pivot points, actuation points, measurements for your mechanism when you actually make the parts. Anyway, we're going to start off with a sketch on our front plane and make a corner rectangle going out from the origin. This is going to be our reference for where our drivetrain sits in the field. Let's dimension this to be 6 inches off the ground. We get this dimension from our drivetrain, so if I was to just move over to where we made our drivetrain and our assembly, we're basically just going to see that from the top plane where our drivetrain is to the very bottom of the wheels, let's make a point right here, this little dimension right here, sorry if I move out of the way, off the ground on the z-axis is going to be 5.9. I'd just say, 6 inches is going to work for you, so we're going to label that 6 inches. Alrighty. Now that you have your reference laid out for your drivetrain, you're going to go ahead and make 2 lines, one going out horizontally and one going directly up. And this is basically going to give you reference for where your bounding box is for your intake. So let's say that first gave you a constraint that's saying basically your intake cannot reach over a certain distance. Let's say for this challenge, 14 inches. It cannot extend 14 inches out of your robot. So this is going to basically be our do not cross line. Make these construction real quick. You can do construction with either Q in your keyboard or construction, by the way, up here. Alrighty, so now that we have that defined, let's say that our game piece, or what we're intaking, is going to be like a 9-inch basketball, like kickball, something like that. Let's dimension this out to be 9 inches. And I already kind of made it tangent by dragging it out and making it tangent to this line here. But you can do the same thing by just, clicking the edge of your circle and then the bottom line right here and clicking T on your keyboard, or you can go over here and click tangent. Alright, now that you have that defined to the bottom line, you're going to also make a tangent to the side of your intake. Or, sorry, not side of your intake, side of your drivetrain. Or, sorry, before you do that, I forgot to mention that you're also going to have bumpers that extend out from your robot. The bumpers are going to be 2.5 inches out, and then probably 5 inches tall. There we go. And then make all of this construction just so it doesn't really get in the way. Alright, sweet. So now that you have this defined right here, once again, tangent the very outside. Move some dimensions out of the way so it's all not jumbled up in your face. Now that you have your game piece right here, your 9-inch whatever kind of ball, and your drivetrain and bumpers defined, you're going to make your roller. Our roller is going to be, let's say, 2 inches. Doesn't really matter that much. We have 2-inch rollers. You can also do like 3 inches. Really whatever works. I'd say 2 though, so just because we have this little limit right here, and that might get in the way unless we make it a little bit smaller. Let's go ahead and make another circle inside of your roller, and that's going to be 1.125 inches. And that's going to be, not the right dimension. That's going to be your bearing hole right there. Alright, now that you have that defined, let's make this construction. And basically, see how if I was to make like a ball same size as this one, see how it kind of has its maximum amount of like distance between the roller and your drivetrain at this corner to the very edge of the circle right here? this is going to be our compression distance right here. Basically, the maximum distance that the ball can get inside this corner to this roller is going to be how much compression we're going to have to want on the ball. So making a dimension out from this point to this edge, let's say we want 1 inch of compression. And what that's going to mean is basically you're going to take your ball that you're trying to manipulate and you're going to put about 1 inch more compression down on it than its diameter. So if it's a 9-inch diameter and a 1 inch of compression, it's going to be 8 inches total length. So we're just going to enter 8 inches. And then I'm going to go ahead and define where this is, away from our point right here. Because right now it's basically having a line connected from here to here that this is going to orbit around. We're going to now define where exactly this sits away from that. And to do that, I'm actually going to go ahead and make another circle that's horizontal to our starting one. Make it the same exact diameter. Construction again. And what I'm going to do is basically make a point vertical from there, from the center point of our game piece, and vertical from our roller on the very bottom and top of our roller and game piece, and dimension this to be 1 inch down. I'm going to do -1 inch because it's currently above it. And this is going to mean that when our ball is out like this, it's going to make contact with our roller 1 inch down from our ball when it first makes contact with our game piece. And then it's going to give us 1 inch of compression right off the bat as it goes in and then immediately up into our intake. And just to make this defined, just make it like vertical so we know exactly where it sits. And that's going to make your roller point defined. And the last thing you need for your sketch right here is going to be your pivot point. Basically, our pivot point is just going to be, decently arbitrary. You just want it to be not super far away from and not super close to your roller, and not super close to the very edge of your actual drivetrain and not your bumper. So let's say we make it, I do 1.5 inches away from our edge, and then 1.5 inches from the top. Dimension this out to be 1.125. You can either do that with an actual dimension feature, or you can just click on both of these circles right here and make them equal. Alrighty, and now that we have our pivot point and roller defined, we can move on to making our actual parts. Tune in for part 2 to see that happen.